You ever snap a blurry picture and you wish your phone could, like, magically sharpen it, actually recreate the missing
It
details?
really is like magic, huh?
It is.
Yeah.
That's the kind of AI we're diving into today.
Yeah, we're going to unpack some code today that takes us right to the cutting edge of AI image reconstruction. And get this, it uses your graphics card to do it.
Okay, hold on. My graphics card.
Yeah.
I thought that was for, winning at Fortnite, not reconstructing images.
Well, it turns out those high-powered GPUs, they're good for more than just gaming.
Okay.
They're built for handling tons of calculations at once, which is exactly what we need for this kind of AI.
So it's like my computer is secretly an art studio,
Yeah.
and the graphics card is the easel.
Yeah, exactly. The code that you shared with me, it uses a technique called an autoencoder. Imagine it like this. You take an image,
Okay.
you squeeze it through a bottleneck,
Okay.
and then try to rebuild it on the other side.
A bottleneck. Why would we do that? That seems counterintuitive.
That's the beauty of it, right? By forcing that image through that bottleneck,
Right.
we force the AI to learn the most important features,
Oh, okay.
the essence of the image.
Got it.
It's like learning to sketch the outline of something
Right.
before you fill in all the details.
God, so it's like learning by simplifying, right? So instead of memorizing every single pixel, it's figuring out the basic shapes and patterns.
Precisely. And that's what makes autoencoders so powerful for image reconstruction, right? They learn to represent the image's core information in a compressed way, which is incredibly useful when we're dealing with blurry or incomplete pictures.
Okay, so I'm with you so far. We've got this autoencoder thing going on.
Right.
We're using the muscle of my graphics card, thanks to something called CUDA, which I definitely want to hear more about, by the way, but before we get lost in the weeds, can you give me a real-world example of where this kind of technology is used, just so I can kind of wrap my head around it a little bit?
Absolutely. So one fascinating application is actually in the field of medicine.
Okay.
Imagine taking a blurry X-ray or like a low-resolution MRI
Right.
and using AI to reconstruct it with crystal clear detail.
Wait, really? That's possible?
Yeah, it is. And it's already happening.
Wow. By training an autoencoder on thousands of medical images, we can teach it to enhance existing scans, potentially reducing the need for additional procedures,
Yeah.
and improving diagnoses.
That's seriously impressive. It's amazing to think that my love for high-end graphics cards might actually have some real-world benefits in healthcare.
Yeah.
But let's get back to the code for a moment.
Sure.
You mentioned that this code uses something called CUDA. What exactly is that, and why is it so crucial in this whole process?
Okay, so think of CUDA like this. It's the translator
Okay.
that allows the AI to understand and use the incredible processing power of your graphics card. Without CUDA, we'd be stuck with a much slower process, like trying to reconstruct a detailed image using a child's box of crayons instead of a professional artist's set. So it's more than just a speed boost. It's like giving the AI the right tools for the job.
Yeah, you got it. CUDA unlocks the parallel processing power of the GPU,
Right.
which means it can handle tons of calculations simultaneously.
Right.
This is essential for deep learning tasks like image reconstruction, which involve crunching through massive amounts of data.
Fascinating. This is already blowing my mind, and we've only just, scratched the surface of this code. There's this whole world of AI and image processing that I never even knew existed.
Yeah, absolutely.
But before we get ahead of ourselves, let's dive into this code a bit deeper, shall we? I'm dying to know how this autoencoder actually works its magic.
Absolutely. Let's take a closer look at how this code is structured, and we'll break down some of the key elements.
Excellent. Now we're getting to the good stuff.
So at its core, this autoencoder is built using a neural network.
I've heard that term before, neural network. It sounds kind of intimidating.
Yeah, it's really just a fancy way of saying that we're mimicking the way the human brain processes information just with code.
Okay, that makes sense. So we're essentially building a digital brain that can learn to reconstruct images.
Exactly. And just like our brains learn from experience, this neural network needs data to learn from. That's where the MNIST dataset comes in.
MNIST dataset, that sounds familiar.
You might have heard of it. It's a classic in the world of machine learning. It's basically a huge collection of handwritten digits from 0 to 9. Think of it like the alphabet for teaching a computer to recognize handwriting.
Right, like digital flashcards. So we were showing these digital flashcards to our AI brain, and it's learning to recognize the patterns in the numbers.
Exactly. And here's where it gets really cool. The autoencoder takes these handwritten digits and tries to compress the information, like squeezing it through that bottleneck we talked about.
Okay, I'm picturing a digital funnel now with all these handwritten numbers getting poured in and compressed. So what happens next? How does it go from this compressed mess to a clear reconstructed image?
That's where the decoding part comes in. The autoencoder isn't just compressing the image, it's also learning how to decompress it, how to reconstruct it from that simplified representation.
So it's like a double agent. First, it's a master of disguise, shrinking down the image to its bare essentials. Then it becomes a master art forger, meticulously recreating the original image from memory.
That's a great way to put it. It's all about learning to represent the image in a way that highlights the most important features.
It's incredible. But I have to ask, all this talk of neural networks and data compression makes it sound incredibly complex. How do we even begin to write code that can do all of this?
Well, that's where the ingenuity of the Python code you shared comes in. This code snippet is like a masterclass in building and training an autoencoder.
So walk me through, what are some of the key ingredients that make this code so special?
Well, for starters, there's a clever technique called batch normalization that helps to optimize the learning process.
Badge normalization. I have to admit, that sounds a little intimidating. Is it as complicated as it sounds?
Not really. It's just a way of organizing the data so the AI can learn more effectively. And imagine trying to learn a new language, but the words are all jumbled up and out of order. Batch normalization is like organizing those words into sentences and paragraphs, making it much easier to understand.
So it's like giving our AI a structured textbook instead of a random pile of vocabulary flashcards. I like it. What else is going on in this code that makes it so effective?
Well, another important element is the use of something called the atom optimizer.
Atom Optimizer, is that like a personal trainer for our AI brain, pushing it to learn faster and better?
You're on a roll with these analogies, and you're pretty much spot on. The atom optimizer helps to fine-tune the learning process. It's like having a coach that can adjust the training regimen based on the AI's progress, making sure it's always improving without getting overwhelmed.
So it's like having a personal AI whisperer guiding our digital brain to its full potential.
Precisely, the atom optimizer plays a crucial role in helping the autoencoder achieve those impressive image reconstruction results. It ensures that the AI is learning from its mistakes and constantly improving its ability to capture and recreate those essential image features.
It's all so fascinating. We've got this incredible code that's essentially teaching a computer to see and rebuild images from scratch. But how do we actually know if it's working? Can we actually see the AI's progress as it learns?
That's a great question, and the answer is yes. The code you provided actually includes a way to visualize the results.
Oh, wow.
Yeah.
Really? So we could actually watch as the AI learns to reconstruct these images?
Exactly. You would be able to see the original MNIST digit right next to the AI's attempt to reconstruct it. It's often quite amazing to see how much detail it can preserve, even though it's essentially redrawing the image from a simplified representation.
That's amazing. So we'd be able to see it go from a blurry mess to a recognizable digit.
Yes, it starts by capturing the broad strokes,
Yeah.
the general shape of the number. Then as it learns, you start to see finer details emerge, curves, line thicknesses, even subtle variations in handwriting.
Wow, that's seriously impressive. This little code snippet is basically performing digital alchemy, turning data into art right before our eyes. You know, we've covered a lot of ground here, from the basics of neural networks to the intricacies of batch normalization and atom optimizers. It's amazing how much complexity goes into something as seemingly simple as reconstructing an image. But I have a feeling we're not done yet, are we?
You're right, there's always more to explore. We've talked about the how this code uses an autoencoder and leverages the power of CUDA to perform image reconstruction. But now I think it's time we shift gears and talk about the why is this technology so important, and what are some of the other ways it's being used today?
You read my mind. Let's talk about the bigger picture, because I have to admit this all sounds amazing, but I'm still trying to wrap my head around why this matters.
Yeah.
So we've established that AI image reconstruction is seriously cool, and that CUDA is like giving it a super-powered boost. But I have to ask, where does all of this actually matter in the real world? It still feels kind of futuristic to me.
It does, doesn't it? But the applications are already here, and they're impacting our lives in ways you might not even realize. Remember that medical imaging example we talked about earlier?
The one with the blurry x-rays? Yeah, that one really blew my mind.
Well, that's just the tip of the iceberg. This technology has the potential to revolutionize healthcare. Imagine being able to diagnose diseases earlier and more accurately, all thanks to AI's ability to enhance and reconstruct medical images.
That's incredible. Are there any other fields where this kind of technology is making a big impact?
Absolutely. Think about restoring old photographs or damaged artwork. AI image reconstruction can breathe new life into these precious artifacts, revealing details that were once lost to time or damage.
Wow. So it's like digital archaeology, but for images.
Exactly. And the applications go even further. Think about environmental monitoring. With AI image reconstruction, we can enhance satellite images to track deforestation, monitor glaciers, or even assess the damage after natural disasters.
It's amazing how this one technology can be used in such wildly different ways. It's like having a magic wand that can sharpen blurry pictures, restore faded memories, and even help us understand our planet better.
It really is remarkable. And we're only just beginning to scratch the surface of what's possible as AI continues to evolve. Who knows what other incredible applications we'll discover for image reconstruction.
This has been an eye-opening deep dive, to say the least. I've learned so much about a field I knew next to nothing about.
And that's what makes these deep dives so rewarding, uncovering hidden connections, exploring cutting-edge technologies, and sparking curiosity.
Well said. I think the biggest takeaway for me is that AI isn't just some abstract concept anymore. It's here, it's powerful, and it's already changing the world in fascinating ways.
Absolutely. And the most exciting part is that this is just the beginning.
I can't wait to see what the future holds. This deep dive has given me a whole new perspective on the power of AI, and I'm sure our listeners feel the same way. Until next time, keep exploring, keep asking questions, and keep that curiosity alive.